everyone, myself Pragati Jadhav, and today the topic of my presentation it is anti Parkinson drug. So without wasting time, let's get started. Firstly, we see the introduction of this Parkinson. Parkinson, it is nothing but a neurological syndrome discovered by the scientist James Parkinson. And majorly this Parkinson seen in the old person, characterized by the tremor, rigidity, akinesia and the posture. These are all the symptoms of this Parkinson. Next one we see the physiology of this Parkinson. The major physiology it is a degradation of this dopaminergic neuron in a substantia nigra in an agrosternal tract of the basal ganglia. Means there is an imbalance occur between the dopaminergic and the cholinergic system. Simply there is a lower the level of dopamine and increases the level of acetylcholine resulted into the Parkinson. This is all about the physiology of this Parkinson. Next one we will see the anti-Parkinson drug and its classification. Majorly the anti-Parkinson drug is classified into the two types. First one is a dopaminergic drug and second one it is an anticholinergic drug. Dopaminergic drug is further classified into the 6 types. First one is a dopamine precursor, example levodopa. Next one is a dopamine agonist, further classified into the 2 types. Ergot and non-ergot, example is a bromocriptine and the ropinol. Next one is a peripheral decarboxylase inhibitor, example carbidopa, benserazide. MAO-B inhibitor that is salicylene, rasazyline. Salicylene is also known as D-pyranil. And COMT inhibitor, example entacapone and the tolcapone. Dopamine facilitator, example amantadine. Next is anticholinergic drug. Anticholinergic drug is further classified into the 2 types, anticholinergic and antihistaminic. Anticholinergic example procyclidine and antihistamine containing example promethazine and orfiprinidine. This is all about the classification of this anti-Parkinson. Next we see the mechanism action of this anti-Parkinson drug. Friends, we all know that the dopamine it is a drug which do not have ability to cross the blood-brain barrier, but there is a presence of levodopa which has the ability to cross the blood-brain barrier. But peripherally, levodopa it metabolized to form a dopamine and 3-O-methyl-dopamine in a presence of enzyme COMT and dopa decarboxylase. So we need to stop this metabolism of the levodopa. For that purpose, we need a dopa decarboxylase inhibitor and the COMT inhibitor. Okay, so dopa decarboxylase inhibitor uses a carbidopa and benserazide, and COMT inhibitor uses is a tolcapone and entacapone. Now the levodopa it is enoughly available to cross the blood-brain barrier. In a brain, levodopa it is further metabolized to form a dopamine. And dopamine is further metabolized to form a toxic metabolite. So we need to stop this formation of this toxic metabolite. For that purpose, we need a MAO-B inhibitor that is salicylene and the rasazyline, and a COMT inhibitor that is tolcapone. Friends, always keep this sentence in your mind, that is tolcapone it is only one drug which has the ability to cross the blood-brain barrier, while entacapone do not have the ability to cross the blood-brain barrier. But tolcapone has a major side effect, that is hepatotoxicity. Now the dopamine it is enoughly available to show its action, and it binded to the dopamine receptor that is D1 and D2 and shows the anti-Parkinson action with the help of dopamine agonist that is a bromocriptine and the ropinol. This is all about the Parkinson and its introduction, its physiology, anti-Parkinson drug classification and their mechanism of action. Thank you friend for watching my video. Thank you.